And as we said, once you get to this point, you can now look for the current in the load resistor by doing what? By saying that if V is equal to IR, now you need the current in the load resistor. That will give you the voltage VTH all over RTH plus what? RL. Remember, this RTH and the RL are in series. As you can see on this board, they are in series. This is a series connection. So for you to get the current in this resistor, we also know that in a series network, the current flowing in this one will be equal to the current flowing here. So to get that supply current, we have to do the total R, let me say RTH subscript L to be equal to RTH plus RL. So if this is equal to X plus Y, let me say you get XY. So XY becomes your RTH. So whatever you get here, so you can now say here that the VTH over XY will give you what? The IL. So when you get the IL, that will be the current flowing in the what? In the load resistor. That is what we said when we were dealing with the Thevenin's theorem. That was when we were dealing with Thevenin's theorem. Remember, we said the voltage will be in series with the RL. The voltage will be in series with the RL, unlike that of the Norton theorem. So as I said, the Norton theorem states that what? It is possible to simplify a linear circuit to its equivalent circuit, consisting of a single current source and a power resistance. Now, as we can see on the screen, if we are not talking about Thevenin's Norton's theorem, Norton theorem. Norton's theorem. So here we said that what? We can simplify any linear circuit, and as we said the other day, a circuit is linear if it uses only standard passive components. A circuit is linear if it uses only standard what? Passive components, such as what? For a circuit to be linear, so for a circuit to be linear, we must have what? Standard passive what? Components. And the example of these components are: one, you must have a resistor. Two, you have an inductor. And three, you have what? A capacitor. So when you have this, you say we have what? A standard what? A passive component. Also, you have to note that most voltage sources, batteries, and current source are also what? Linear. So we said most voltage sources, batteries, and current source are what? Linear. So now we talk about the Norton equivalent circuit. We are saying that whenever you are given any circuit, you can draw that circuit, unlike this is for the Thevenins. Here you have this. You have this. As I said, this is your VTH. This can be your RTH, and this is your RL. But for Norton theorem, we are saying that your circuit will look like this. So this will be your IS, this will be your RS, this will be your what? Your RL. So here we can call this as your point A to point B to look for the voltage drop. Now, as you can see the screen, or you can see the board, you see the difference between Thevenin's theorem and Norton's theorem. So for Thevenin's theorem, when you finish resolving that linear circuit comprised of a passive element, you are going to draw this equivalent circuit to look for the current in the load resistor. But when you come to the Norton theorem, you have the supply, you have the current, you have the RS, which is the Norton equivalent resistance. You have the load resistor. So you'll be able to calculate for the current in the load resistor. Without much ado, let's take some examples to verify this particular theorem under consideration. So let's look at example number 1. We have a circuit of this manner before us. I'll say this is 20 ohms. This is 40 ohms. This is 10 ohms. Give me some few seconds. I want to send this thing to class rep. Please resend the link I sent to you for the class. Send it to my WhatsApp right now. So as you can see, so what are we going to find the Norton equivalent of the above of this circuit? We have to remove what? The load resistor. So we have to remove the load resistor. So if I'm removing the load resistor, the equivalent circuit now will look as this. Will look as this. Will look as this. So now we have 10 ohms. We have 20 ohms. And we have the supply, which is the 20 volts, and the 10 volts. Now, how do you get the equivalent this thing here? Now, to get the equivalent resistance here, when you look at the circuit, this one here, I can call this one R1. I can call this R2. Whilst, okay, let me name it from here. R1, this will be RL, which is R3. This is R2. So at this point, I can look for the total resistance here. That will be equal to R Norton, will equal to what? These two resistors are not in series, they are in parallel. So 10 times 20 all over 10 plus 20. So here 10, 20, 20 times 10, that will give you what? Who can tell me what 20 times 10 will be? Yes. Priscilla.
200.
20 times 10 is what, Priscilla?
200.
Is that, are you Priscilla?
200. 200.
200. Then wisdom. 10 plus 20 is what?
30.
30. So when you divide, you get 6.67 ohms.
7.
You get 6.67 ohms. That will be the class P. Have you sent me the WhatsApp? Okay.
Yes, I've done it.
Okay, I've seen it. Thank you. So that will be the equivalent resistance. That will be the equivalent resistance. Okay, so now, having done this, we need to get the what? We need to get the current. We have to get the current. So to get the current, as you can see, because we have removed this, we have this 10 volts and this 10 ohms. We can look for the current using Ohm's law. Here also we can use the current using Ohm's law. When you look at the direction of flow, the current are flowing in the same direction. They are going in this direction. They are also coming in this direction. So for that purpose, I can add up the flow. So I can say that IL will be equal to what? This is I is equal to V over R. So 10 all over 10, which will give me 1 ounce. Then if I say IL1 and also say IL2, that will give me what? 20 all over what? 20. That will give me what? 1 ounce. But as you can see, the direction of flow is going. So I can say my IL will be equal to what? 1 plus 1, which is equal to 2 amps. So I take this as IL. Now, you come back here, you have to draw the equivalent circuit. You have to draw the equivalent circuit. Remember how to draw the equivalent. No matter how complex that circuit is, you must draw the equivalent circuit. Now, to draw the equivalent circuit, as I've shown you earlier on, you have something like this. You have something like this. This will not be in series, but will be in parallel. This will not be in series, but will be what? In parallel. So you have something of this sort. So this is your RL. Sorry, that is not your RL. This is your R what? Rn. This is your load resistor. This is your what? The current. So when you look at our calculation, we got 6.67 ohms. And the RL here is 40 ohms. But the current is what? Is 2 amps. Now, when you look at this particular circuit, for us to calculate for the current in the load resistor, unlike that of the Thevenin's theorem, where you just do your voltage divided by the summation of the resistors, you can see here we have two resistors connected in parallel. And you all know that when you have two resistors connected in parallel, you can use the product over the sum. So to get my final RT, I will say Rn times RL all over Rn plus what? RL. That will give me 6.67 times 40 all over 6.67 plus what? 40. Yes. Who is there? Let me call names.
5.72.
Michael.
Yeah, 5.72.
Michael. Victor.
Hello, sir.
Victor.
Yeah, 5.72.
6.67 times 40 will give you what?
6.67 times 40.
Yes.
Perform.
266.8.
266.8.
You said?
266.8. 266.8.
Yes.
So 266.8. So Daniel, 6.67 plus 40 will give you what? Daniel.
46.64.
46.6 what?
67. 67.
67. Anthony, what will be the final answer?
Sir, the Anthony's are 2.
You said?
Am I the one? Because the Anthony's over here are 2.
You are the one. You are the one.
Okay, the final
Yeah, the
answer
answer will be 80.
5.7167 ohms.
5.72 ohms.
16.
Somebody is raising the hand. Who is raising the hand there?
Yes, there's another Anthony. That's the other Anthony I'm talking about.
Latifat. Speak. You raised your hand. Speak.
Yeah, so I was trying to call the answer.
Okay.
5.72.
Okay. So now we know the RT. So we can look for the what? We can look for the current for the this thing. We need to get the voltage. We know current, you have to get voltage. So now, if you know current and you know the resistance, remember V is equal to what? IR. So current is what? 2 times. So that resistance is what? 5.72. When you multiply, what are you going to get? Douglas. 2 times 5.72, what will you get? Benedicta.
144.
Felix, what will you get?
1144.
Say.
2 times 5.72 will give you what?
Sir, please, can I speak?
Please, I will give you 11.44.
44.
Okay, 11.44. What's the unit? Felix.
Volt.
Volt.
Sir,
Volt.
sir, vote.
7.44 volts.
Okay, thank you. Volt. So now, if we know the voltage, we can now look for the what? We can now look for the current. So to get the current in that resistor, so IRL will be equal to the supply voltage all over what? RL. That will give me 11.44 all over 40. 11.44 all over 40. So what would that give us now? Who is the acid?
0.286.
0.286 watt amps.
Amps.
So this is the current flowing through the load resistor. Let me get you a class exercise to do right now whilst we're on the class. to make the class look more interesting. To make the class look more interesting. Okay, I've gotten one here. So let's solve this as a class exercise. So class exercise. I call it classwork. So you have this circuit before you. This is your RL, which is 2 ohms. So this is R1, this is R3, this is R2, this is 4 ohms, this is 1 ohms, this is 7 volts, this is 28 volts. So find the current flowing through the load resistor RL. Please, you can start work now.
Hello, sir. Hello, sir.
Yes.
So please, under the R3, is it IE or
Where?
under the R3?
It's 1 ohm.
It's 1 ohms.
Yes.
Okay, thank you, sir.
You're welcome.
Sir. Sir.
Yes.
So please, from the previous example we just saw,
I'm listening to you.
is when we go to a point, he brought 40 over there. That was RL.
Yes.
It wasn't stated in the question. Okay, it's okay.
Yes.
Sorry.
Okay. This is it.
Thank
Here's the question. This is the 40 here.
you. Okay.
I say
Yes,
the
sir.
40 is the load resistor, this one. So
Okay.
you always be making reference to the load resistor. But that is where you're looking for the current flowing. So solve this question right now. And let's continue.
Then we can't see the question.
Hey, the question is right before you, my brother. I believe you can all see the question.
Yes, sir.
Okay.
So the first one, is it 28 volts or 25 volts?
It's 28 volts.
Okay, thank you.
Hey, this thing that is clear like this on the screen, you're asking me whether it's 28. My brother, why? Let me write it.
Taking guy. So,
Yes. Yes.
please, we just joined. Is it Tevis theory?
My brother, read the question very well. I've written everything on the board. Using Thevenin's theorem, find the current flowing through the load resistor RL.
You said Norton's theorem.
Sorry, Norton's
Norton's
theory rather.
theorem. Yes, sir.
Hello, everyone. Hello.
Hi.
Yes, as you are solving, you can
Hi,
interact in
sir.
the chat session. You can also have conversations as you are working. You can ask questions from your friends.
Okay.
Charlie, what are you doing? What have you gotten? Feel free. Okay,
Okay.
but don't make it rousy. Do it constructively.
Okay. Which formula are you guys using? The
You
load
can utilize the chat
resistor
session properly.
40 ohms. This one is 0. This is 40 ohms. That should be the first one. This one is what if this one is 7?
Mute yourself if you want to talk. Then you open your mic. Let's do it well. Mute yourself if you have any question. Then you open, you talk, you mute yourself again. I'm recording the session.
Sir, this chance that I are giving there, though.
Rizla,
Sir,
what
yes.
have you gotten?
What am I getting for what?
Sorry, sorry, I got 0.8.
Which one? Which one did you get 0.8?
The para.
Yeah, the two resistors in parallel, you get
Correct.
0.8.
Yes. And then the
The second one I'm on it. I got
IL, the IL, no, you get 14.
yeah, I got the same thing.
And then the total resistor, when you redraw the circuit, the total resistor, I got 0.57 ohms.
Okay.
And then the voltage, no, I had 7.98 volts. And then the total current flow, the current flowing through the load resistor, I had 3.99 amps.
Okay.
You can try and see.
The total resistance I'm making over there.
That one you do R Norton times the load resistance over R Norton plus load resistance.
Okay.
That's what you used to get. And the R Norton is the 0.8 that you had. Hey, Jesus Christ.
What?
Presla.
Yes.
Presla. You
Yes.
said you got the current for the load, the total current for the load. What was your figure?
I don't. So is it the final answer
The total
or
current for
what?
the IL.
14.
You got 14.
Yes.
Okay.
Please, how did you get 14?
But in the first one, he did
Please, how did you get your 14?
and I'm explaining, you know, listen.
Yeah, I'm listening.
You use the current over the resistor. No? Are you saying the first one? No?
So meaning,
Third
Prisla,
and you use the arrow to determine the current flowing through that particular the one second. Do you understand?
Okay.
So you do it
Prisla,
28 over the resistor there, which is R, and the other IL2 7 over 1, which is R3. Then you add all the answers that you add. Yeah, I had 7. Yes, I had 7. 7 plus 7 is 14. I don't know if it's correct. So if second, then if
I got.
That's 14. Yes, Prisla is true. That's 14.
It's 14
Anthony.
amps. Anthony.
Yes, please.
You're Anthony.
Yes,
Yes.
please.
Anthony.
Yes, hello.
Yeah,
So meaning
which of
say
the
you
Anthony's?
use anyone. Yeah. So Charlie, meaning say you use adjoint later. So meaning say you do RT is equal to R1 times R2.
Yeah.
Yes, please.
All over. Yeah,
All
all
over.
over R
no,
R1
in the
plus.
question, no, they labeled R1 and R3. So you remember, you not use the first one you did. You do it R1 times R3 all over R1 plus R3. Remember, they've labeled it R3,
Okay.
not R2.
Okay. Thank you.
Hello.
So great, I got
So that's
14.
4 times 1.
Rizla, are you listening?
4 plus 1.
Rizla.
Yes.
Please, what's the formula for finding the current?
Huh?
No, when you are using
14.
when you are
What's the
using
formula
current
for finding the
divider
current?
rule,
I'm calculating for the voltage. I got the voltage 1.14.
The voltage
Okay,
equals
Priscilla.
and the I was 14. So 14 times 0.5. You should calculate for the total resistance before you can be able to calculate for the voltage. Because when you read all the circuit, you get
Okay, so
0.8 as the
Priscilla.
true resistance, and then the 2 ohms as the load resistance. So you calculate for total resistance before you can be able to calculate for the voltage. So Adela, go back and calculate for the total resistance.
Okay.
The RT,
Priscilla.
I got 0.57.
Hello.
Yeah, the
Hello.
total resistance
Yeah,
is 0.57.
the
Hello.
RT is
Yeah,
0.8.
0.57.
Hello. Please against something.
Then the
Priscilla,
voltage I got
Hello.
1.14.
Prissy.
Hello.
Yeah,
Then
the
the current
voltage is
across.
1.14. Yeah,
Hello.
well done, Charlie.
So
Let me suggest
the
something.
current flowing through the resistor is 0.57.
0.57. Well done, Charlie.
Anthony.
Well done.
Yeah.
Hello. I suggest you
Anthony.
should
Well
use
done.
the approach of the other
Anthony.
question. Solve the second one. It's just the same thing. Just the change the parameters.
Anthony.
Anthony, you said the voltage you got how many?
The voltage is 1.14 volts.
1.4. 1.4 volts. Yeah.
114.
Well, yeah.
The
1.
current, how did you find it?
The current
You
across the resistor is the
The
current you
current
do it voltage over.
0.57.
no.
Yeah,
It's
the current you do this way. Voltage over the load resistance.
It's 2 times 0.5.
Anthony.
Anthony, watch it again.
I said
Uh,
you do it the current you do it voltage over the load resistor. So that will be 1.14 over 2. So you get 0.57.
Yeah, Anthony.
did you find for the current along with this thing, the 2 volts?
Yeah, I love the 2 volts. You get 2.
You see, current Priscilla, please. Current
Priscilla,
along
please,
the
what's your
28
final
volts,
answer?
then current along.
Another 2 is 2. It's 2 volts. It's 2 amps.
Then you add them together.
So I just want to find. No, you get 1. So you have to get 2.
Anthony.
Uh-huh.
Anthony.
So finding voltage is total
When you get 1,
current
you get
times the
2.
resistance.
Yeah, any Anthony, Charlie.
When voltage get current and resistor.
Prissy.
Felix.
Yeah.
So,
Yeah.
what are we going to?
Hello,
The
Priscilla.
first one,
Are we going to the current and
the
resistor?
RT, I guess 0.8.
Okay. Yeah, you will get 0.8.
No,
Is it correct?
0.57.
Yeah, it's correct. It's correct.
The RT is it correct? 0.8.
Correct.
No, you are
So I
supposed
got
to get
0.57.
0.57.
0.57.
Yeah,
So right now we find
it's
I'll find for the
0.57.
current before the voltage, right?
It's 1.4.
You find for voltage first before the current.
Yes.
Hello.
Yeah.
No, if I'm for the current
Hello.
for the voltage.
The final answer is
No.
14.
So I'll find for the current before the voltage.
Sorry, the voltage before the current. Sorry.
Voltage. No. The
Voltage
current,
before the current.
Yeah, voltage before the current.
Yeah.
the
Yeah.
voltage is current. So you find for the current first. You get the current, then you calculate for the voltage. Otherwise, you can't.
No, you get.
Okay, so the
You get
current
the
is
you get it.
RL. I bet the formula. I bet somebody help me here.
See, if you didn't find for the voltage, you can't get the current too.
Plus L2. Then you put the figures from.
If you didn't find for the
Oh.
Now you need to
So what of
calculate
the
for the
current?
voltage before, so that when you get to use the formula, you use the formula I is equal to V over R.
Okay. So V is equal to
So if you find the
28 times Or am I wrong?
What is 28?
The voltage.
What are you find for? The IL or the RT?
The voltage.
The voltage. The voltage, the formula is V equal to I times R.
I times R.
The I times R, then you put the figures, then you calculate it, you get 1.4.
1.4.
No.
Yeah, so the
Please,
voltage.
you are
Or
mistaken.
1.4.
The current over there, the I over there is 14.
Yeah, if
You are supposed to add the current along the distance, the 28 volt side plus the current along
Yes.
the 7. You add them together. Then you multiply it by
Yeah,
the
You add
zero.
them together.
the total
Zero.
resistor.
Zero.
Yo.
Hello, zero.
Yeah.
You did it.
I mean,
So the voltage, if V is equal to I times R.
Ah.
yeah,
yeah.
Okay.
yeah.
So the I is hold
The
on.
I
The I is
uh,
I is 2. And R is
Where the
0.
resistance be?
The resistor be 0.57.
Why 0.57?
so you calculate
You
the R,
calculate it
I thought
for
the resistor, the total resistor for both resistors
The
are
total
0.8,
resistor is
right?
0.8.
Yeah,
0.8.
0.8.
No, that'll be that one.
That
so
is
The
the one, the
total
first one that is in parallel. That one you get
Yeah.
the first one
0.8,
is
but the
0.8.
total
Yes.
current,
Yes.
total resistance is 0.57.
You see, say the total resistor be 0.8. You go add up like the load resistor.
You
That
go
to the
add up
power
to the load
few resistor. They will give you the.
You know go Adam.
No, you don't go add that
You
one.
go do this one.
You know go Adam,
Yeah, no go add
you go
them.
You
come
know go
join
Adam.
them, you go come join them
You
for
don't
the
go add
one
that.
you short
They
circuited.
come over the
At,
product.
at that point, the load resistor is taken off.
You come and solve
No,
it
it is fine for
with
the.
parallel with the RL.
Yes,
Yeah,
redraw again.
there will be some over the product.
Yeah, some
when you
over
are
the
solving,
product.
don't draw. When you
Yeah.
are solving, don't
They
draw.
will give you the 0.57.
When you are
57, yeah.
It be
get
product
Yeah.
over sum.
Yeah, sorry,
Yeah,
product
product
over
over
sun.
some.
Yeah, product over sun, Charlie. Then we will
They
get
will give you the
0.57.
Yeah.
Yeah, so the 0.57, you multiply it with the IS, giving you 0.33.
So
No,
multiply by 2.
you multiply by 2. That's a load
That's the
resistor.
difference.
Okay.
Load resistor times the current.
Multiply by 2. You get 1 point.
Yeah.
You get 1.14.
1.4.
Yes.
No.
Okay.
I mean, you get a.
So you get
IS is
you get
not 14, it's
7.98 volts. Yeah, 7.98.
Hmm. Charlie,
I
guys,
want
are
me
you
at
sure?
3.99.
Okay.
Tell it.
The voltage be the
Francis,
voltage be
Francis,
1.14.
Francis, how did
Yeah,
you
the
get the
voltage
14?
will be
How did
1.14.
you get the 14?
So you divide it
So,
by two. You divide it by the two.
The IS, no. How did you get the IS 14?
that is where you are going to first calculate for the current, the current in both the resistance. So you take you see we have two sources, 28 and then 7. So you take the R1 and then you divide it by 28. So 28 over 4, you get 7. And then you take the R3, which is 7, and then you divide it by the 7.
That is
This one is not like that. Check what.
this
No,
one
no,
is like
no.
that. So we are going the same direction. So the direction is
This
the
one,
same.
Relax,
So just
no.
divide it
relax,
by
See,
direction, no
this one is
matter.
Newton's
relax.
theory. It's not like they are in
Not
terminals or they are
yeah.
in inverse or this one is
This one is
Newton's.
not
In
in
Newton's
theory.
is different.
The current
This one is
passing
not in
through
theory.
the RL is 3.99 amps.
Yes. That is the final answer. 3.99.
Yo.
Yeah, the final answer is 3.99.
Yes, the final answer is
Yeah, the final is
3.99.
3.998.
No, guys. Are you sure? Let's
Yes,
make a
Daniel.
question very well,
Yes,
please.
that is
Wait.
the final answer. That is the
Wait,
final
wait,
answer.
wait.
Daniel.
Final answer is
Yes.
0.57.
Yeah.
So
Yeah,
let's
0.57 is the final
That's
answer.
your
That
that's
is
your
the
total.
current in the
That's the
resistance.
total resistance.
Daniel.
yes.
Yeah, so I got to the place with the voltage. V is equal to 2 times
2 times 0.8.
Okay.
Yes, 0.8, yes.
No, that is when you are finding the total resistance. If you
Yeah,
are
the
finding the
total
resistance,
resistance.
it will going to be 0.8 times 2
8 times
divided
2 over
Yes.
times 2 over.
Load. Yes.
That's the
Over
total resistance.
the product over.
If you are finding the volts, it's supposed to be the current times the resistance.
Yes.
So your total
That will give you
resistance,
1.14 volts.
no, it's not going to. It is going to be 0.5.
No. So
0.5714.
No. So it could be V is equal
Hello,
to 2
class.
times 0.8
Hello.
equal to 1.6.
No.
Hello.
Hello,
Yeah,
yes, sir.
hello.
Sir, we are with you.
Yes, sir.
Okay. Let's look at it. So now, looking at the circuit we have, first of all, take away the load resistor. So, if I take away the load resistor, so it means the circuit like this.
Just mute yourself.
If you're not talking, mute your mic.
So here we have 4 ohms, 1 ohm, 12, 7 volts, 28. Now, see if I want to look for the RS, say these two are involved, 4 times 1 over 4
plus
+1. That will give me 4 over 5, which is equal to what? That will be what?
0.8
0. What?
0.8
ohms.
Now, to get the short circuit current, which is equal to I Norton, that will give me Here I have V over R, I have V over R. So if I say I1 is equal to V over R1 plus V1 over V2 over R2. So let me call this one IS. So I'll get 24 over 7 plus 7 over 1. This will give me what? So this is 4 right now.
28.
So it's 28. Thank you. So 28 all over 4. 4, 7. So 7 plus 7. Am I right? So we get 14 amps.
Yes, please.
We get 14 amps as what the current. You know what you are looking for.
We're
So
looking for the voltage.
is there?
We are looking for the voltage.
So how do you get the voltage?
So the voltage will be the total resistance times the current, which is 14.
When look at you are right, but when you look at the question, when you look at
I've not gotten this.
when you look at this portion, is when we get here, we'll do that. So now we know the current already. We know this thing, the R total. So I can draw the equivalent circuit. I can draw the equivalent circuit as this. Remember how Norton circuit should be. So this is R Norton. This is the RL. And RL is 2 ohms. R Norton is 0.8 ohms. 0.8 ohms. 8 ohms. And the current is what? 14 ohms.
14.
So now you want to get the equivalent resistance of this two. This thing you have in here. You have 0.8 and you have 2 ohms. When you look at what you have, we've gotten 0.8, we've gotten the R nothing, which is 0.8. We've gotten, we have the load. So now you want to calculate for the voltage. As you come here, you can see here that since we know the supply, we have to calculate for the total resistance. So here, what are you going to do?
Please don't who are not talking to me.
Sir, please, your voice is not stable, sir.
When RL, somebody is open the mic. Open the mic. The feedback. So that will give me Rn times RL all over Rn plus RL, which will be equal to 0.8 times 2 all over 0.8 plus 2. That will give us what?
1.6 over 2.8.
1.6 all over 2.8.
So it will give you 4.48.
It will give you 0.57.
4.48.
Hey, why 4.48? How?
0.57.
0.57.
0.57.
So that will give us 0.5.
0.5741.
5714. You are using calculator, you are calling different answers for me. Serious.
No, it's
No, we are getting
0.57 exactly.
0.5714.
You
So,
can't get
because
0 point. Look at the number here, my brother. This is simple arithmetic. Look at this. The denominator is bigger than the numerator, so it will be 0 point. Then you add 0. Can you see it?
Yes, sir.
yes, sir.
Yes, the denominator is bigger than the numerator, so it can't be 5. So here you get 0 point, you add 0. Am I right? And if you add 0, this decimal, so what will you get? 2 in this thing will give you how many? That's how you do your arithmetic. So
0.0.
So we have this. So now I want to get the voltage IR, which will be equal to, I know the current 14 times 0.571. That will give us what?
7.98.
7.98 volts.
7.1.
98 volts.
7.98
volts.
Is it 7.98 or there's something there?
When you use
Volts, sir.
when you use
7.99.
0.571, you get 8 exactly.
If you use what?
If you use 0.571, you get 8 exactly.
Okay. 14 times 0.571, right?
Yes. Yes, sir.
So 8 volts. Now, when you look at this, you want to now get, the current right now, as we did here.
Yeah.
You know the voltage now.
Yeah.
That is the, yes.
Please, when you multiply 14 by 0.571, you will get 7.994.
And 7.99,
Sir,
that's
I've
8.
run it.
Run.
Yeah,
Oh,
run
okay.
it. Yeah.
7.99. When you touch the 9, the 9 becomes 1. If that one falls on the next
Yes, sir.
9, that 9 becomes 10.
It's 8.
So the one will hit the 7, it will be 8.0.
Okay, sir.
So now, for us to get the current in the load resistor, that will be the voltage over what? The R what?
RL.
Which is equal to 8 all over what? 0.371. Am I right?
0. Sir, not 0. Something. It's 2, sir.
It will be 2.
So it's a bit 2.
Sir, it's
Yes, sir.
It's 2.
So 2. Thank you.
Yes.
Yes. So 2. So over 2. So what will we get?
4 amps.
3.99.
4
Hey,
amps. 4 amps is 4.
So you get 3.99, still 4.
2 into 1. 2
Yes,
in
sir.
8 is 4. 4 amps.
3.99 is where is it coming from?
The 3.99, you approximate it to give you
It's the
4.
rounding of the numbers. Some people are not rounding the numbers. If you round, you get your 4.
Okay, let's try this and see. Let's try this and see. I'm drawing another circuit for you.
Okay.
This one will be this thing.
Now, please, is there any other formula for working this?
Formula. This is the theorem.
Yes, sir.
Matthias.
Sir. Sir.
Okay.
Charlie, mo mute mo mic ne yesre mo a o Charlie.
Let's try this. Let's try this.
Okay,
sir.
Yes, sir.
Hello.
Hello.
Yes, sir.
So this one it will be R2 R3. or guys?
Yeah. That's
Or
Yeah, sure. Yeah, correct.
oh, okay.
No. Is it not R1, R2, R3?
no.
No. We have to find one first. So was
Charlie, are you sure, Charlie?
We are going to take off the load resistor. That is
Yes.
the 100 ohm. Then
And
the
you
find
will now
hundred.
total.
draw. So for you
Yeah.
to
So
get
if we
there,
take off the load, it will now be left with the R3 and the R2. Or
what of the
No,
R1?
the R1
the
is also
R1.
there.
The R1 is at the other side. Or you don't understand.
Akulamo. Yeah, I see.
Actually,
You,
because
you,
this
you
one,
have to solve R3 and R2 in parallel.
Yes, that's what I mean.
Yeah. So
Hello.
let's deal with that one.
So we're going to solve R1 and R3 in parallel. And we add the 200 ohm to it.
Hey, Charlie, calm down.
When we remove the load, when we remove the load,
So
R2
now,
the R2
there it
200
is.
ohm is going to for current being loaded. You understand?
Yeah, but you see how the thing they there. You see R2 then R3 they parallel. You see that thing. So me and I will solve the R2 and the R3 first. Or
Okay.
Bro,
Let's
be like
try
if
That
the
is
let's
R
try our hands on that
it
one.
be like if the R1 and R3 where you go so first, so then you add this thing.
yeah,
Why
then
you
you
go?
come
okay.
solve for the R1, then you take join your
Both.
final answer you get for the
See,
R2
I
and the
think
R3.
Yeah, that's what they
Or
see for you. Yeah, I sure it be true. Yeah.
voltage did the top there. You know, go fit find the R1, the R2.
You find R1 and R3 first.
You know, go fit find that one. Why you go pass?
Then
Why the
let's
current?
find
Why you go
R3,
find
R3 and R2.
R1 and R3 are parallel to each other.
Yeah, R3 the
Yes,
R2. So you go find.
R1
you say
and
R1.
R1 and R3
Mm-hmm.
are parallel to each other.
Okay.
uh,
Okay, what
R,
about the
R,
R2 and the R3?
R2 and R3.
Is that what?
R2 and R3 first before the R1.
Then the
Yeah,
R1 will be
R2
serious
and
to it.
R3, Charlie. Yeah, R2 and R3.
I want make we do that one first. Then we come the final answer we go get for the R2, R3. Then we come join them plus the R1.
The R1.
You know, go fit
Or you
be
go
this one.
subtract them from them. Oh,
You go.
Charlie.
Charlie, one like make we just stay on course, so Charlie.
Isla. Isla. Isla.
Please let
Then
me
why don't
cut.
you use rather this?
Charlie, me
I want
I
plus.
finished this thing.
I want
The
is
R2, then the R3.
You get to the R1 and the R3. You get 45.45 ohms.
Eh? What's the
Would you
45 point.
approximate it?
No, I will.
you?
I know go
No,
see.
it is 200 times
This
200 times
if
500
it's not 200.
all over.
It's
Is
one
it?
of us
no. It is
I
50 times 500.
I don't want plus
Make everybody listen. Make everybody listen. Obianti. Make
Fifty
munye
times
Five
munye.
500.
hundred.
R2.
No,
I dey
one
count.
after the other. Yes,
The
make you
thing
just
the
listen
thing
to
go
that
be
Listen,
one.
like make
Then
you
we find
listen
the
to me.
listen,
SN.
Make you listen to me.
listen.
The thing go be
Li-
R2 times R3 all over
Mm-hmm.
R2 plus R3. We are now a bracket, now a plus R1. No. If
Then
it's
now
true.
long. Let's do the
Yeah,
simple
yeah,
one
yeah.
after
Yeah.
the other.
So say we
Then
go
we
start
R1
submit
all
and
to
at once.
R3, R1 and R3 are parallel to each other.
okay.
So it
Then
will be 50 times.
why don't we do it R1 it is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Then we find the LCM.
That
We
one,
find the
that
No,
LCM.
no,
one,
no,
that one.
that one no go work. Oh, you can't use that
It go
formula
work.
here. I'm not sure. No,
It go work.
you can't use it.
That one is for series circuits. Any
So
Juma.
listen, listen to me. Listen.
Because
R1, wait, listen. R1 and R3 are parallel to each other. So you do it 50 times 500 over 50 plus 500. When you finish solving it, then that one is in series with the 200. Do you understand? So you add them together.
Now what you are saying is still wrong. Oh.
Is what's wrong?
The
Make
R2
yourself.
and the R3, they are still in parallel. They are not in
Listen,
series.
listen, everybody calm down.
Which one?
Everybody calm down.
The
Calm down.
R2 and the
Yo,
R3
Calm
are
down.
still in
listen.
parallel.
Everybody calm
You
down.
man,
Calm
listen.
down. See,
Listen.
see,
What the
man, see.
suggestion where your man brings say what be the name? R2 times R3 all over
And
R2 plus
2
R3
plus R3
No,
into
no, no, no,
bracket
no,
bracket.
no,
plus
no,
R1.
no.
Plus
Everybody calm
R1.
down.
Now
Calm
the
down.
size been now being bio.
Boys, guys,
The
see,
R2 and
everybody
the
calm down.
R3 they are in parallel.
Boy,
Hello,
boy,
listen.
see.
Hello.
Hello, hello.
Hello.
Yes,
Yeah.
yes.
So
Calm down.
the thing
Everybody
is
should calm
that
down.
the thing is that
Yes, sir.
I was thinking, when you look at the circuit, R2 and
Yeah.
R3 they are in parallel. So first of all,
Mhm.
you solve R2 and R3. After that,
Yes.
you bring the
Okay.
final answer at where R3 is. Then now the circuit will look like a series. So you can add the 50 to the answer that you got
to the
for the R2
yes,
and R3. That's all.
yeah,
Is this
So
so?
yeah, simple,
After I
very
add,
simple.
what did you
No,
get?
So the final answer, Prince, how much you get? The final answer.
Yeah, I got
You
1
get
point.
192
Correct. 192
It's
point
245.
86.
86. Yeah, if you run
So
it, you get
if you
86.
do yo listen, if you do like how the guy they talk say into bracket plus the 50, yeah, you go get the same thing.
You get
The
the same thing.
same thing,
Yeah,
forget your
You
more
go get the
actually.
same thing. So it be now be that.
So
Prince,
as
do
they
you get
know,
what we
they
are?
know they understand now. You go explain them to as them go understand. Because as the boy talk, it be like sharp, like straightforward.
Yeah,
So you
so
have
the
to
boy they
break
talk
it down
say
for them. You understand? So that
okay.
be your I
Okay.
explain to
For
you,
example,
explain
let's say the R2 times the R3 all over R2 plus R3 into bracket plus R1. You understand? So the R2 is 200 times the R3 is 300. Okay. So you times that one, you get how much? If
You
you
don't
get
have
the answer,
300
let me
here.
put it. So I say 500.
Say
500.
300.
So then if you over 200 plus 500, that one you get 700. Okay. Okay. So after that, when you divide the what is the name? The 1,000 whatever plus the 700, you get 142.86.
140.86.
86.
Thank
Yeah,
you.
if you
Then
run
you
it,
add the 50 to it plus
you're making
50. That's when you get the 192.86.
1.86. Yeah.
You understand? Then we continue for there.
The one
Or you
so
still
that
don't
means the one
understand?
you are solving for the one at the 10 voltage source, right?
We are solving from the R2
If the
R3
network may be my
first.
place or
So we are closing
Ah,
the 100, the load over there. We are closing it. We are not using that one at all. So right now we are using the R3 and the R2. You understand?
Yeah, the source is only one. I
Then
mean,
you
the source is only one.
yeah, there's source is only one. Yeah.
I'm talking about the the RL, say whatever. RL. You see it's 100.
Hello.
We are
I'm
not
having a
using that one.
suggestion.
So me, I'm using the R2 and the R3. Me to me no. Maybe I me year and if you want me find no count here. Say what I say.
So
What
after
again?
all, you
It's
get
what did you get?
after all, you get 92.86.
You said
Right? You get
the total answer
192.86.
92. Yes,
Yes.
correct. That's it. Then we
So now
continue
you have your
from there.
current and you have your voltage. So now you are calculating
Yes.
for current.
So the
Yes. So
current will get
we are
like
not going to calculate for the current.
0.052.
Voltage over resistance, which will be 10
10
over
over.
So right
19.
now, boss, I beg calm down. So right now, which one are we going to now?
Hello.
What are we solving for?
You. I'm coming.
Right now, we are solving for
Load
current.
current.
Yeah, that's the load
Hello.
current.
We are solving for the current, right?
Yes.
Yes.
I was talking for the
Okay.
total current
So,
too.
Hello.
so the total current will be what's the formula?
Voltage over
Over
resistance.
Resistor.
Voltage over
Resistance.
so it's going to be I is equal to V over R.
Yes.
Yeah.
Okay. So I is equal to the V is 10, right?
0.0518.
The V is 10.
Yeah, the V is 10.
Okay. And what's the name? The R is what?
192.86.
192.86. So let's punch that one on the calculator. Let's see what we'll get.
Zero point zero
0.0519.
You said
0.052.
You still use the same
No,
thing.
it's
so it is
0.0519.
the answer is I is equal to 0.052.
518. We are
Okay.
Have a different
So I've also gotten that side. Okay, I've also gotten that side. So where are we moving to next?
No, that current is the final answer.
That's the final answer.
a different theory.
Yes, because
You forget
those
the
two
other
resistors
you
tend
Adam.
to be in series.
So
No,
you
not
have to
that.
calculate for the total resistance.
That's this one. It seems to be in series. So in series, current is the same.
Yes. So right now we are going to what are we going
Right
to
now,
do next?
Right now, no. We'll draw the circuit again. Then the
Okay.
total resistance will be in parallel to the resistance load.
Okay, so
You
hold
get
on.
it?
Let me draw mine. So at that point, redrawing the circuit.
So now we
Redrawing
know
the
we know our
circuit.
current.
Yes.
We know our
You
So
have
right
current.
now,
to redraw it again.
yes. So right now we are redrawing
Right.
the circuit. So still our
So
voltage
right
is
now our current is 0.0518.
okay. Then what about the voltage?
And the total resistance will be 192.86. Then the load 100.
Nobody's
We will
talking
now
about
find the Rn. The resistance, not what.
yeah. Darling, nobody
Hello,
they
I have
talk
a different theory. Hello. Let's ask you. Can you, when you remove the load resistance, listen. Hello.
Yeah, bro, talk.
When you remove the load resistance, the RT,
Who is that?
the 200 ohm, is going to be what? Void. Current means loaded. Are you understanding something? Hello. So if 200 ohm resistor is what? Void. we can do a solve R1 and R3 in series.
What
Then
what
after
you are
that,
saying?
Your
I
we
can't
voice,
solve
hear
it
you.
in
So
your voice
parallel
did
with
raise
down.
your
Your
voice
voice
more.
did down.
Your voice is too down.
when we remove the load resistance. Can you hear me now?
Your voice is
Can you
down.
hear me? I
Say
said
your
when we
voice is
remove the
low. It
load
seems
resistance.
like you are using headset or Bluetooth or something else like that. So your voice is low. So like raise your voice more.
Can you hear me now?
Yeah.
I said when we remove the load resistance,
Mm-hmm.
the R2, the 200 ohm resistor will become void. Current won't flow there. So we can solve R1 and R2 in series. When we solve R1 and R2 in series, our total resistance will be 550 ohms. After that, we'll solve it in parallel with 200 ohm resistor to give us 146.67 ohm as the total resistance.
Okay.
You understanding
You
that
say
clearly?
100 and what?
Please,
100 and
please,
what?
Gideon,
146.67
100 and
Gideon
what?
Chireme, or is it Chireme?
for the
Chireme,
total
Gideon,
resistance.
Yes,
please
sir.
mute yourself.
Yeah,
Your
please.
background is very noisy.
Yeah, you were saying 100 and what? You mentioned some final answer.
146.67
140.
6.67 for the total resistance.
So the total resistance,
That
mean
is
to me,
when we solve
if I use
five.
if I use the R1 and the R2, I
you do
got
something for
okay in
Mhm.
total at that side I got 142.86. Before I added the one to it, R1 to it, that's when I got
That's the
192 point.
Felix. That is the one you did. But I'm talking about the theory I'm making now is when we take off the
Yeah.
load resistance, R2 will become void. It will current will not flow there. There will be no work done over there. So we are going to solve R1 and R3 in series. Then after that, we solve it in parallel with what 200 ohms. So the total it
So
will
you
be
that's how you
200
want us to do
times.
it.
No, that's what I'm suggesting that
Okay.
because when you move the load resistance, 200. If you are solving 200 ohms and 500 ohms in parallel before you come and add it in series with the
Yeah, because right now, right, I'm not getting your question, but to me, we've gotten to the place to find the current, right, guys? Is that not where we've gotten to?
Yeah.
That's I is equal to V over R, and we say our V is 10, right, and our total resistance that we were working previously, we got 192.8, right?
Yeah.
Yeah, so 10 divided by 192.8. Me, I got 0 point.
86.
Yeah, I got 0 point. 0 point. Hello. I got 0.0516. 18. Sorry. So right now, one person was saying we have to, draw back the circuit. Or am I lying? So I just want to know how we are going to position the circuit and before we continue. So please, anyone with any idea?
So right now, it's like right now we've gotten our current, right? We've gotten our current.
Yeah. What's your current?
So now the total current is 0.0518.
Okay.
Who got the final answer?
Is that it?
So please, yes. So please help us draw the circuit and let's continue.
So right now we will use the this thing, current divide U to find the current through the short. That's my idea.
All working with an idea. Okay, he said that knows the best, but we are all working with an idea. So, the idea, but obisu the about. That's how it works. So, please, anyone with another idea.
Okay, now where you have got
Hello.
to, where like you get the current, you found the current.
Okay.
If you read the circuit, if you read all the circuit, now you have
I
to
did go
find the
class on
total resistor. Like for that particular circuit, got that circuit, you have the load and then the northern resistor there. So now you do it product over sum, like how we did the first one.
Yes. Yes.
When you get the
Okay.
answer, then you come and find for the current flowing through the circuit you've redone. That's how you do.
Okay.
So when you find the
Prissy.
your Rn will be 66.53.
Eh?
To check.
Prisla.
Yeah.
Prissy. Yeah, so please, in redrawing the circuit, okay, so what and what do we have?
So if you redraw the circuit, you have your supply current, which is the 0.0518. Then the northern resistor, you have 192.86. Then the load, you have 100 ohms. That one is already in the question like that. Then you do that over time, which is Rn times RL, all over Rn plus RL. So when
please
you
come
do
again. So the formula will be what?
Okay.
So the formula will be
that is the product rule of finding the total resistance.
Rn times RL, all over Rn plus RL.
Okay, so Rn is equal to R.
Yes. So that's
No,
why you get 65.
No, RT is equal to Rn times RL all over Rn plus RL.
Okay.
Then you solve for it. You can run the Rn to make it 193 because it has a lot of distance. So you run it and then you solve so that I can get a figure that
total resistance.
Okay, so that will be RL plus the first one is times, right? Times.
Yes.
Times R what? RS or RT or R what?
I say no.
Because or you still don't get what I mean. I'm the one talking right now. You
Your
say
name.
Felix.
Felix, if they are talking, listen. Right.
Okay.
Oh. I've said it more than 5 times. You asked me after this.
Felix.
Yeah.
So now you do it Rn times RL all over Rn plus RL.
Okay. Sorry. I got it.
So with that, you get 65.5.
So after you get your Rn, what will you do?
So if you get that one will be the total voltage. No, that one will be your total resistance. So you take that one and then you see now you have current and then you have your total resistance. So you need to find the total voltage, which will be V is equal to IR. V is equal to IR, and then our I is 0.52, and then
Relax.
As you come again.
Yes.
The network is not clear, so relax.
Okay, I'm saying now if you find the RC.
So hello.
Yes.
So now the final answer will be 0.0342.
Yes.
0.0.
See, See, you are multiplying it with the load resistance. The value of the load resistance is 100 ohms. Not check. You should check the load resistance volume. It's 100. So you are multiplying. The power rule is going to be 192.9 times 100. The load resistance. If you draw the equivalent.
No, it's supposed to be 0.052 times 6.85.
You see now you have
So the
What
final answer
you guys are saying, we can't hear.
the final answer
Please,
I
are you
got
planning for voltage, total voltage?
the final answer I got is 5.87. Please, is it correct?
Yes, it's
Okay.
correct.
Okay.
What?
Okay.
The final answer?
Yeah.
That's the final. Very, very, very simple.
No, that is not the final answer. That one is for the total resistance.
For the total resistance.
Yes, for the total resistance. So now we have our total resistance, and then we have the current. So you multiply so that we get our total voltage. Before we can now calculate for the current in the load resistance.
So that would be
0.052
times 65.85, right?
Yeah.
Yes.
No.
So you get.
You said 0. What? 0.05.
0.052.
Yeah.
Okay.
Two.
Okay.
Times 65.85.
Yes.
Okay. So please, what's the formula?
So you get 3.443.
For what we are finding right now.
You get
We are finding
40.
for the total voltage.
Yeah, the total voltage.
That's the total voltage.
Yeah, that's the total voltage.
Okay.
So right now we have to find the total current in the load.
After some the 0.065. What did you get?
We had 3.43 for the total. Yeah, 3.42. You can round it. So we have now. We now have the total voltage. You said we now have the total voltage. So now we have the total voltage, and then they are saying we should calculate for the current in RL. So you take the total voltage, and then you divide by the load resistance.
The load.
So which is yes. So our
which is
RS.
total. Please, the total voltage I got 7.89.
Total voltage is 3.4.
3.4. 3.4.
Is it not 0.052?
Yeah, 3.43.
Please,
it's not 4.3 because you can't run it.
It's not 4.3. It's 4.2.
4.2 is 4.2.
It doesn't matter. We are all still now. It's the same thing.
It doesn't matter. When you are solving for the total resistor and you round it, your answer will become 0.43. If you don't round it, it will become 40. It's the same thing.
Okay, so please. 0.052 over 6, 5.87.
It's times, so not over.
You said it's times.
It's multiplying, not over.
Okay, thank you.
And please, I think you should check something. You see, in the question, you see where the voltage is. You see the plus and minus, which means the current is flowing up. The current is flowing from resistor 2, and then some will come to R3, and then to go to R4, which is the load resistance, before it comes back to the R1. So I think R1, and then I think after we are done with this, we should try another way. Like you see, somebody was saying we should take the
Hello.
Yeah.
It's a theorem. This is the theorem. This is the formula we used to solve. You cannot change it. Like
no, I'm not changing it. If they will,
No,
I know,
what
but
you are
I'm
saying, no, what
You
you are
see,
saying.
no,
Okay.
no. What the set was saying is that he is fine using the LCM. You understand? When you
Yeah.
have using the
no
LCM, you use substitution, and you will get it.
Rich,
But it's a long way.
Yeah.
Rich.
Yeah.
You see, from the start, you see, we use the R2 and then R3 in para. Do you remember?
Yeah.
So what of if the R1 and then R3 that they were supposed to be in para, then after we are that, the R2 will be in series with that. Because you
Yes.
see, check the sign, the positive and the negative. You see where the current is flowing, you always current flow from the positive side. Do you get it?
Yeah.
So I think maybe I'm only suggesting, I'm not saying it's like that. I'm suggesting whether the R1 and then R3 are in para. And then
So what you are saying right now is like you are doing try and error.
no, I'm not saying
No,
you are
I
doing
don't.
try
How,
and error.
Prince, don't
to
say
what I'm
that
I'm
right now.
saying,
suggesting.
Say
to what
also suggestion
to what we
also
are
one
saying
of the
here,
table.
to what you are
You have to
saying here,
focus on one side.
R1,
You have to know that what you are
R1
doing is
and
the right
R3 are in
process.
parallel.
Yes.
Yes.
R1 and R3 are in para. So which means if they are
Yes.
in para, which means what we've done, we are
No,
wrong.
no. R1 and R3 are series.
Is that what?
No, they are in
Please, can you
para.
come in?
See,
R2
see, under normal circumstances, when the current is flowing from the circuit, if you check where the arrow is, now that I've placed some arrow, I don't know if it's arrow or I can't see it. Yes, it's arrow. That means the
Yes.
current is flowing to R1 first. And
Yes.
No,
so
that
So
using
if
one.
that
the current is
That's a
flowing
common
from
kind
that
of
place,
a
which means
mistake.
R1 and R3 they are in para.
See, because of the node, the junction, the R1 and
Yeah.
R3 are in parallel.
Yes. R1 and R3 are in para.
Yes.
and it's because of that same node, R2 and R3 are in parallel. You cannot be in series because of the node.
Let's come in and give us the final
So,
answer.
so we have to
So
make
you see, when you
one
solve it
part
finish,
series
when
then work
you
first.
finish solving the I1 and I3, you redraw the circuit. When you draw the
Yeah.
circuit, they will be in series to the 200, the
Yes, they will be in
resistor.
series with the 200. That's what I'm saying. That's what I'm saying.
Okay, so right now you've gotten our resistor nothing. So now what are you
Current.
solving for?
Hello.
Hi.
Yes.
We are done.
Hello.
Hello,
We
sir.
have got the last.
Yeah, you've done well. I'm taking note of the conversation. You've done well. I've been sitting here all along listening to what you are doing. I was solving the question with different softwares. I want to try and show you softwares. So I was doing some simulations whilst you were doing the theoretical work. Okay, let's look at this. Yeah, I think we'll end the class with from here. Okay, as you can see on the board, you said what?
Sir, Martin, please continue.
Say, I solved it. I got the current passing through the RL to be 0.13 amps. I don't know whether it's correct or not.
Please, since here is talking, allow him to talk and then let's all hear him, please.
Don't say I did not hear it. To talk
Let's solve now. So now, from the question you can see on the board, we have one voltage source. We have one voltage source, which is this. We have a node here, as you can see. So this is the positive current flow from positive to negative. So when you look at this side, these two resistors are in parallel. They are in parallel. Now we have to take off this load resistor. When you take off, these two still remain in parallel. Now, for you to get the total resistance, because we have this single source here, this and this are in parallel, resolve them, they will be in series with this one, because if these two which are in parallel becomes one, when this produces a current, it will flow through this resistor and back to this side. So that will make this side and this side. When we resolve this, becomes a series branch. So let's see what we have. Let's see what we have. So between the 200 and the 500, you do product over the sum. Between the 200 and the 300, you do product over the sum. So let's say RT1 be equal to, that will be 200, or let me redraw the circuit. Let me redraw the circuit so that we can see what I'm doing properly. Okay, so here, let's start from here. The circuit goes this way. Oh God, let me see. So here we have 10 volts. I think here we have 5. Please, if I make mistake, let me know. This is 200. This will be 100 ohms. This will be 50 ohms. These are RL. Now, when we take off the RL, our circuit turns into something like this. No. Our circuit becomes something like this. 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 So this is a 50. This is 500. This is 200 ohms. This is 10 volts. Remember, this is where we have the RL. So when this particular source produces, current come this direction, some will come here, some will come here. So these two are in parallel. So to get the equivalent there, that would be, let's say RT1 will be equal to, if this is R1, let me use a red color. Erase this. If this is R1, R2, R3, R4, which is equal to RL, so that will give me R3 times R2 all over R2 plus R3. That will give me 200 times 500 all over 200 plus 500. We have that there. So at this juncture, we are going to get, I think this will be
100,000.
What will you get? 100,000 all over 700. That will give us what?
142.8.
142.86.
142.6 ohms.
0.8.
The numerator is not 100,000. It is 1,000.
86. 0.86 ohms.
86 la.
0.86. Yes, it's 0.86.
So that says no 0.8.
Sir, I beg, designate one person to be mentioning it for you. If everybody is mentioning, you will not know like which one to write. You both to relax. One person should be mentioning it. If everybody, he will not know what to write.
So R equal to R1 plus RT1. That will give me 50 plus 142.86. That will give me 192.867 ohms. Now I know the RT. I have to get the IS. So I is equal to V over R. So what V is 10 all over R is 192.867.
Yes.
So it's
Sir,
0.86.
sir, please, before you go, you scroll it up, please. I want to bring up something. Please, the listen, when we go to the number, you got 142.86. So I did it, let's say 100,000 over 700 please, it's not plus 100,000. It is 1,000.
Do
Okay, 1,000.
your
Okay,
Hey,
please.
you mean
Charlie.
200 times 500 is 1,000?
Hey, oh my God.
100,000. It's 100,000.
Sir,
What is
I'm bringing
1,000?
up something. Oh. What I'm bringing up is
So
serious, please. Please.
here,
So I got
after that, we'll get 0.5, 0.0, 0.0518 amps.
Okay.
This I can make it 0.0518 times 10 power 3. That will give me what? 51.85 milliamps.
Okay.
Why?
Milliamps. Now we have the IS. We have to calculate for the voltage in the the 50 ohm resistor. When you look at the question here, when you have a parallel circuit, the current varies while the voltage is the same. But here we have to look for the voltage here because we can easily get the voltage because we know the current there already. So now to do that, we said V in the 50 ohms will give me I times R. And that current is what? The 51 times 10, 51, 50, this is, so you can use this
51.83.
as, you can use the 0.0518 times 50. That will give you what? 2.9 something, 2.8, no. That will give you what? Who is there? Priscilla.
Okay, that's I got it.
Is Priscilla there?
So it will give you 2.59.
2.59.
2.59.
59. Yes, sir.
So 2.59 amps. Now we know 2.59 amps to be, so 2.59, right? That will be voltage rather than current. V equals to IR, that will be voltage, so V. Now, for me to know my absolute V2 supply voltage, that will be the 10, which is the first voltage we had here. This voltage here, minus the voltage here. To get, we will now know the rest of the voltage, which is roaming circuit.
Can you go over that part again?
So now we have this minus 2.59. That will give me 7.41 volts. Now, I know this to be my voltage. So if this is my voltage, I can now get my I. I can get my I naught in now because I know I know the V2 there, which is like your Norton voltage. But here we are not dealing with voltage, we are dealing with current. So what are you going to do to get your I Norton? So I Norton here will be equal to this voltage we just got, this voltage all over what? When you come here, you will see that this 200 ohms here, this 200 ohms here is connected to this 100, but this and this are in parallel, but this and this are in series. So because this one is not there, if I get a voltage, if I get the voltage here, that voltage here will be equal to the voltage here. So to do that, I have V2, which is equal to the 7.4 all over 200 ohms. All over 200 ohms. I will get what? 0 point something. 0 point, somebody help me. 7.4, 200. Francis, do you have a calculator there?
Sister, good evening. Me pero bani bio.
Yo.
Hey,
Asa,
So it will be 0.037. 0.037.
So now this is milliamp. Sorry, this is amps. Right? This is amps. So if I want to convert, you use 0.037, there's a number outside that.
No,
so
no.
So I here will be equal to 0.037 times 10. If you multiply by 1,000, you get what? 37
milliamps.
37.1 milliamps.
1 milliamps.
37.1 milliamps. Now, I know my IN. I know my IN now. Now remember, we know IN, we know RL. The question is, do we know the RN? Do we know the RN? That's the question you ask yourself now. So how do you get the RN? To get the RN,
Sir, please
I'm
scroll up a
going
little bit. Sir, please scroll up a little bit for me.
to get the RN, you can see that the 50 ohm resistor and the 5 ohm resistor are in parallel when I entirely open that circuit. Even when we consider this circuit independently, you will agree with me that the 500 ohms and the 50 ohms are in parallel. Am I right? If you consider this circuit independently, the 500 ohms and the 50 ohms are in parallel, but they are in series. Both of them, when these two you are in parallel, will be in series with this. Now, why am I going that route? Because at this stage, I have to exclude this particular resistor. Now, I'm not solving because I'm looking for voltage. I'm solving so I can get my R Norton. Now, to do that, I will say that my R
Sir, please, you've muted your mic.
Hey, sorry. What did you hear last?
Sir, please,
I
can you
will
go
say
top
my
small
R.
so that I can screenshot
Last
the
word
list?
was I will say
Sorry.
my R.
Sir, please, you've
Sorry.
muted again. Sir, please, you've muted again.
Somebody is muting me. I didn't mute myself.
Yes, sir, you are not the one doing it. You are not the one.
Somebody
You
is
are not the one
muting
doing
me.
it. It's somebody who is doing that foolishness. You are not the one.
Sir, please, some people are removing us from the group. Oh. It's not fine.
So if I take off this thing, I have something like this. Without the voltage source. So this is 50. This is 500. This is 200. Remember here we had the RL, which is equal to the 100 ohms. Now, if you look at it critically, this and this are in parallel. As a result of this open portion, this and this will be in parallel in series with this. So 50 times 500 all over this will give me what? Calculators. Who is there? Asiedu.
245.45.
You get what?
245.45.
245.
0.455.
0.45. Everything right?
Yes.
Ohms. So if we have this, we have to redraw the circuit now. Thevenin's equivalent circuit. So now we have this. No. You draw this here. This is Rn 245.45. This is RL 100. Now the question is, what is our IN? That's what we got here. 0.037. So we can say 37.1 milliamps. So 37.1 milliamps. Now, you want to get your voltage. You need to get the total resistance here in parallel. So RTN, let me call it that way. So Rn times RL all over RL plus Rn. That will give me 245.45 times 100 all over 245.45 plus 100. That will give me what? Calculators.
71.05.
Are you sure?
Yes, 71.05.
So you get 71.05. That will give us what? Ohms. Now, what is the next thing for you to do? What is the next thing for you to do? Yes.
You apply Ohm's law.
You find the
You will
voltage.
find voltage.
So if you are looking for voltage, that will give us what? 37.1 times 10 negative 3 times 71. Am I right? Am I right?
Yes, you are right.
Yes.
So what would that give you? What would that give you? What would that give you?
2.636.
2.63.
You get V is equal to 2.63 volts. Now, if you know that, you have to calculate for the what? For the current.
Current.
For the current now. So the current in the IRL will be equal to what? The new voltage you got, which is 2.63 all over 100. That will give us what?
2.66. 2.66, not 2.63.
102.63. 102.63.
Is a lie.
26.3.
The voltage is 2.66.
Is that?
It's 263. It's 263.
2.66.
0.026.
26.3.
0.0263.
263.
Amps. Milliamps will be what?
Milliamps.
Carbon.
It will be what?
That'll be
It will be
26.3.
1 ounce. 263.1 ounce.
Milliamp
Okay.
will be 26.3.
So far, so good. We've come to the end of today.
Sir, please, why times 1,000?
I'm converting it to
You
million.
are changing it to milliamps, so you have to multiply by 1,000.
One question be this. Jesus.
Is it difficult?
So this one there is difficult.
Please, when you are coming, prepare to write your mid-semester exam.
Difficult.
Sir, please, wait, some people remove us from the platform. So please, if you can send us the video so that we can go through it, we'll be
Who
happy.
remove you from the platform?
Sir, we don't know.
The Lord is your shepherd.
Yes,
Sir,
You
please
shall
scroll
not
it down for
want.
me to see the voltage, the V. Sir,
So
scroll
please,
it down for me to see the V.
video of
Yes,
this.
Scroll it down. Yes, sir.
Yeah,
I want to see the
please,
V.
send us a video. Send us the recording.